So let's dive into Newton's laws of motion, that is Pulley system. So this question, I'm going first to explain everything you need to understand under Pulley system. The best way you can do this is to pause the video, try to solve it, and then see how I'm going to solve it. Okay, so let's begin. When we're talking about Pulley system, in this case there is no friction at all. So the question is, the figure below, okay, the figure below shows a 5 kg block A which hangs from a string which passes over the frictionless pulley and is joined to a 12 kg block B which lies on the frictionless table, of which from the diagram here they were supposed to give us the diagram, but I think I lost the diagram. So from the question, it should be like this. I have swapped this because they are saying 12 kg block which lies on the frictionless table. So meaning that B is here, and this is 12 kgs, and this is A, that is 5 kgs. That's why he's saying the figure below shows a 5 kg block A which hangs from a string, yes, which passes over the pulley, or which passes over a frictionless pulley and is joined to a 12 kg block B which lies on a frictionless table. So this is the diagram now. So the first part is saying find the acceleration of the two blocks, but two, find the tension in the string. I'm going to use two methods on how we are going to solve this. Okay, so one thing I want us to understand is that for this system to move in this direction, it is because of the weight of this object. So this object A, which is block A, has got the weight of m1g or mag. Okay, so now therefore we can say that the summation of forces that makes the whole system to move in that direction, since there is no friction, it is just because of the weight, which is mag. It's because of the weight of block A. According to Newton's second law, you replace this by mass times acceleration. But in this case, this one, it is not only pushing itself, but it is also pushing the 12 kg block. So we'll say ma plus mb times acceleration being equal to ma times that. So then we can divide both sides by ma plus mb. Even here ma plus mb. These will cancel out. Therefore, A will be equal to ma times g, ma plus mb. So if we were to plug in the values, what is ma? Is 5 times 9.8. I divide that by 5 plus 12. Therefore, acceleration is 5 times 9.8 is 49. Then 49 divided by 17, because I know that 5 plus 12 is 17. So it is 2.88 meters per second squared. That is my acceleration. Now, after finding the acceleration, we can now go ahead and find the tension force, which is now part 2. So how do we tend to find the tension force? You choose. So if I'm to get this block, which is M, I'll get it like that. Here we have got the tension force. Here we have got mlg. The system is moving in this direction. So if the system is moving in that direction, one thing we should take note is that the acceleration will be negative if the system is going toward negative y direction. The summation of forces in y direction, we have got the tension force pointing upward minus the weight force, which is mag. Replace this by negative ma, because the acceleration is negative, that's why it's negative ma. Then we have that. So now it's ma times a. Then we have that. Shift this to the other side. I'll have this. Okay, so I can factor out m, or I can write that. So the tension force will be ma g minus maa. It's the same thing. Then I can factor out ma g minus a. Plug in the values. What is my ma? The mass a is 5, g is 9.8 minus 2.88. T will be equal to 9.8 minus 2.88. That is 6.92 times now 5. That should be 36 or 34.6 newtons. Okay, so that's the tension force, 34.6 newtons. Now again, if I want, I can go ahead and use this block, but I should be able to get the same answer. So here the only force I have is the tension force. The summation of forces in x direction, we have only tension force. Replace the net force by mass b times a being equal to the tension force. The mass b is 12 times 2.88 should be equal to the tension force. Therefore the tension force is 12 times 2.88. That is 34.56. if I round it off, 0.6, like that. So you choose which method to go with. So I've given you the first method that you can use to find the acceleration and the tension force. So now when finding the tension force, you just choose one method, that's all. So I'm just trying to show you all the methods. Now the method 2 which I'm going to show you is this. You first come up with a free body diagram. Remember that the tension force is 34.6 newtons. You first come up with a free body diagrams on each block. I'll start with the first one. We said that the tension force is here, then the acceleration is coming down, so it's negative a. So you say the summation of forces in y direction, the tension force acting upward minus then the weight force, which is mag. Replace this by that, should be equal to that. Okay, so shift this to the other side, and then it will be negative ma plus, like that, being equal to the tension force. So if you want, you can say that T is equal to mag minus ma. So we'll call this as equation 1, because we do not know the tension force, at the same time I don't know the acceleration. So I'll put it here. That is equation 1. So I'll go now to the forces in x direction. So in x direction we have what? So we should know that this tension force throughout the rope is the same. This tension force and that one, they are the same. Okay, so the summation of forces in x direction, we only have the tension force. Replace this by mass times acceleration, like that. So you call this as equation 2. So you equate the tension equal to each other. So this will be replaced by that. Okay, so then we'll say mba should be equal to mag minus ma. Shift this to the other side, so it will be mb plus, I have got a, then ma should be equal to mag. Now I can factor out m, so I'll have m. It's the same even if I start with ma plus mb, because it is plus, so plus is commutative. then I have that. Divide both sides by MA plus MB, MA plus MB. So these will cancel out. A will be equal to MAG divided by MA plus MB. And if you remember, this is the same formula which I gave you when finding this answer. Now, how do you find the tension force? So now here you have already derived the formulas. It's just a matter of to choose. It's either you will go with this equation or that equation. So if you plug in the values, it will definitely give you the same thing. 12 times 2.88, and then the tension is 34.56, which is 34.6 newtons. So as you can see, it is something that is very simple. It's just a matter of you following up. Now, in a case where you have been given the friction, how do you tend to work out such kind of problem? If you have got the friction force, I'm going to show you one method, but you have to go back to my videos which I explained under Pulley system. I considered the two methods. So the summation of forces, we said it is MA times G. But now, since there is friction, if there is friction, this has to overcome the friction. So you say minus friction. Okay. Then you say MA plus MB in the brackets times acceleration should be equal to MAG minus, you know that the friction force is mu times the normal force, of which the normal force we're talking about, the only block that is in contact with the table is block B. So it is MBG, that is the normal force. Okay, so you say mu MBG, then A will be equal to MAG minus mu K, then MBG divided by MA plus MB. So this is going to be a formula for the Pulley system, this type of Pulley system when there's friction. The tension force, this one is not going to change. It will be the same thing. And I don't mean the answer, but what I mean is the formula. But for this one is going to change. It's going to be the tension force minus the friction force, because you have got the friction force now there. So try to explore different type of question under this topic, and it's really going to help you to understand more. Thank you.